All right, we're going to finish up Unit 9 here with some solving radical equations. And what I mean by that is just equations that involve a square root symbol or a radical in some way. It will be helpful to recall that exponents and their same roots with the same index, they're inverse operations. And remember, when you solve an equation, you're using the inverse operation to undo all the operations that were done to x, or whatever the variable is. So for example, x squared here is the inverse of the square root of x. Those are opposite or inverse operations. Likewise, the fourth root of x is the inverse of x to the fourth. The index on the root is the same as the exponent. And so you can make a general rule here, that x to the n is the inverse of the nth root of x. So this will help us as we solve our equations. So when you solve an equation that has a radical symbol in it, first, if needed, you want to isolate that radical. You want to get that radical by itself. In some cases, like this first example, it will already be isolated, and so we can start using the inverse of it to solve. So here we have the square root of x equals 5. What we're going to do is just square both sides. Take both sides to the second power. So if the square root of x equals 5, then x is what we get there. The square root symbol and the exponent 2 cancel each other out, equals 25. And you can check that by putting 25 in for x. The square root of 25 is 5, so this equation worked out. Here we have x plus 5 in the radical, which is still isolated currently, so we can start by squaring both sides again. Okay, so we're left with just x plus 5 over here equals 25. And then we solve this. We're going to subtract 5, so x equals 20. Now, for example, see we have a third root. The index is 3. So to undo that, we take everything to the third power. Right, so a little more multiplying, but it works the same way. Remember, when it's just a square root symbol with no index, it's assumed to be a 2. But if you have that index number, that's what you'll use as your exponent to undo that operation. Okay, so 8 cubed is 512, and that equals 20x plus 12. So the third root and the exponent 3 canceled each other out, and all we're left with is what was inside. And now we just solve this. It looks like a two-step equation from here. So we'll subtract 12. We get 500 equals 20x. So now we'll divide by 20, and we get x equals 25. Okay, example D here, we have the fourth root. So we take everything to the fourth power. Okay, so on the left-hand side, we get 2x minus 12. 2x minus 2. I'm not sure where 12 came from. And we get 256. 4 to the fourth power is 256. Okay, and now we just solve this two-step equation by adding 2. So 2x equals 258. And then we will divide by 2. So x equals 129. Okay, example E. The square root of 4x minus 6 equals 4. And this is the first one that the radical wasn't isolated. So we have to start by isolating the radical or getting it by itself. So first we'll add 6. So the square root of 4x equals 10. Now we can take that inverse operation and we get 4x equals 100. Then we can divide by 4. And we get x equals 25. Similarly, on this last one, we do have to isolate the radical. We'll subtract 6. So we get the cube root of 5x equals 5. Go ahead and cube both sides. So 5x equals 125. Divide by 5. And x equals 25. There were 3 that equaled 25. That was a coincidence. But there you have it, 4 that equaled 25. There you have it. First step is to isolate the radical if needed, and then use the inverse operation just like normal. Remember that the inverse of a nth root is the nth power.